Hello, welcome to this final video to accompany the Further Maths Conference calculus session. In this video, we're going to look at the answers to the last two questions on the handout about linking the inverse tan integrals with transformations of functions. So, the first of those was the integral of 1 over 1 plus 16 x squared. So using the technique from the first video, we can say, okay, the half-life on 1 over 1 plus x squared was 1. The half-life on the red graph here, we can say, is 0.25. That's when the graph drops to half its height. We're then interested in this shaded area, and this shaded area is 2 lots of 0.25. So we can now compare that to the equivalent blue area. The equivalent blue area will be the area under the whole of this curve all the way up to x is 2. Those two shapes are similar. So we can say that this integral is the same shape as the integral from 0 to 2 on 1 over 1 plus x squared dx. However, it's been squashed in by a factor of a quarter. So it is a quarter arctan 2. And that should correspond with what you get if you perform this integration algebraically. The second example was a bit more tricky because there were two stretches involved. It's the integral from 0 to 3 of 1 over 2 plus x squared. Well, we can still think about the half-life on this thing. So the half-life here is, when does this drop to half its height? Its initial height is 0.5, it drops to half its height here. That number's a little bit hard to read, but you should see it's about 1.4, which should ring a bell with the square root of 2, and you can actually take out a factor here of the square root of 2 and confirm that that's the case. So here we've got a half-life of square root of 2. 3 then, how many lots of square root of 2 is 3? Well, we can say 3 is 3 over root 2 lots of the half-life. So we can now compare this to the equivalent integral under the blue curve as if it went up to the 3 over the square root of 2. So this should be the same shape, albeit with some stretches, as the area under 1 over 1 plus x squared dx from 0 to 3 over root 2. What are the stretches? Well, it's certainly been squashed down by a factor of a half, so I can put a half in there, but it's also been stretched horizontally, and it's actually been increased horizontally up from 1 to square root of 2, so it's actually that much bigger. Putting all of that together, we get root 2 over 2 arctan 3 over root 2, which is exactly what you get if you perform this integration algebraically. So I'll finish with these videos here, but it's worth commenting, I think, on this last one, that it was relating to trying to relate these transformations of functions. I would suggest doing this after students know how to do the integrations algebraically so they can confirm the answer. The other connection you could possibly make here is that this does feel quite similar to standardizing normal distribution type calculations. It's almost a similar type shape curve, not literally mathematically similar, but has got a shape that looks a bit like 1 over 1 plus x squared. And when we standardize, we're essentially thinking, can we transfer this back by some transformation to an original curve and think about what that does to the area? Okay, but I'll finish the video there, and hopefully you can work through all of these with a handout and that will support you with helping your students use some of these ideas.